Good evening. This is Ina Suresh saying नहीं नहीं मैं कुछ नहीं कर रहा हूँ। पानी पीना तो थोड़ा सा पानी पिला दो यार थोड़ा सा पानी है पीने का और पानी पीने का कैसे करेगा बस मेरा yes. So section 5 concrete general did before also this file shared with you, again sharing with you because it was long back and I forgot what I shared. This is 2014 QCS, in which general introduction, scope, references, definitions, approved products, implementation, approved installers, field quality control, rejected materials, records, and then general. This is part 1, section 5, introduction. This is scope means section includes requirements for concrete work for pipelines, roadworks, runways, structures, water retaining structures, foundations and bases for structures and equipment. This part includes relevant standards, definitions, abbreviations and requirements for testing, facilities, rejected materials and record keeping, and related sections are as follows: aggregates, cementitious materials, water admixtures, property requirements, concrete plants, transportation and placing of concrete, formwork, curing, reinforcement, construction joints, inspection and testing of hardened concrete, protective coatings of concrete, hot weather concrete, miscellaneous precast concrete, pre-stressed concrete, water retaining structures. General quality assurance and quality control, foundations and retaining structures, roadworks, drainage works, mechanical and electrical equipment. References: following standards are referred: ASTM C31 standard practice for making and curing concrete test specimens in field, ASTM C39 standard test methods for compressive strength of cylindrical concrete specimens, ASTM C143 standard test method for slump of hydraulic cement concrete, ASTM C1064 standard test method of temperature of freshly mixed hydraulic cement concrete, standard test method for temperature of freshly mixed hydraulic cement concrete. BS6100 glossary of building and civil engineering terms, and then tests for general properties of aggregates, method of sampling, tests for general properties of aggregates, methods for using laboratory samples, method of sampling, fresh concrete site testing, fresh concrete slump test, This is important. And shape, dimension, other requirements, specimens and molds, making curing specimens for some tests and testing of concrete part 1, sampling a fresh concrete, testing of part Properties of fresh concrete testing for Part 3 making and curing test specimens. Definitions: degrees Celsius, calorie, centimeter, D stands for day, FCK, CYL characteristic, compressive strength of concrete determined by testing cylinders, FCCYL compressive strength of concrete determined by testing cylinders, FCK cube characteristic compressive strength of concrete determined by testing cubes, and FC cube compressive strength of concrete by testing cubes, FCM mean compressive strength of concrete, FCMJ mean compressive strength of concrete age, J days, GGBS, ground, granulated blast, furnace slag, G guts, GUTS, guaranteed ultimate tensile strength, GUTS, guaranteed ultimate tensile strength. H stands for hour, kg kilogram, kg joules, kilojoules, km kilonewtons, I L liter, M meter, M square meter, M cube, cubic meter, mg milligram, minimum minute, millimeter, square millimeter, months, MPa megapascal, kPa kilopascal, MSRPC moderate sulfate resisting Portland cement, OPC ordinary Portland cement, PFA polarized fuel ash, PVC polyvinyl chloride, S stands for second, SF silica fume, SRPS sulfate resisting Portland cement. Ton is 1000 gram, ppm parts per million, micro is 10 to the minus 6, micrometer 10 to the minus 6 meter. Reference to Technical Society Institution Association of Governmental Authorities made in advance with following abbreviations: ASHTO, American Association of State Highways and Transportation Officials, ASI, American Concrete Institute, ASTM, American Society of Testing and Materials, AWS, American Welding Society, BSB Standard, BSCP, British Standard Code of Practice, BSEC, British Standard Institution, CNC, Cement and Concrete Association, CRIA, Construction Industry Research and Information Association, CRSI, Concrete Reinforcement Steel Institute, CS Concrete Society, DIN Dutch Institute of Normal, EU, EN, Euronorm, FSW, Federal Highway Authority, GSO, GCC, Standardization Organization, IC Institution of Civil Engineers, ISO International Organization for Standardization, PCI, Priestess Concrete Institute, QCSS, Qatar Construction Specification, QS Qatar Standards, UKDFT, United Kingdom Department for Transport Products, approved products. Now, approved products, contract specification, contract specific documentation may identify approved products and approved or pre-qualified manufacturers and suppliers, operators using concrete products, implementation, approved installers. Contract specific documents may identify approved or pre-qualified providers of concrete construction services. Field quality control. Contract shall carry out test procedures required by this section and other tests, and test procedures shall direct by engineer from time to time. Test procedures shall be carried out using facilities of an approved independent testing laboratory. Supply, storage, sampling, testing of matter shall be responsible to contract unless contract specifies otherwise. Engineer may also require contractor to take samples of materials and deliver them to Central Materials Laboratory for additional tests to be carried out by employer. Sampling procedures shall be in accordance with BSc and 930 or relevant ASTM standards, and sample sizes shall conform to requirements shown in Table 1:1:1. We will see that minimum equipment required for testing on sites given in Table 1:2. This equipment shall be maintained on site at all times during concreting operations together with necessary scopes, buckets, sample containers, and other items required for sampling. Cube curing tank shall be located in air-conditioned area as shown in Part 6. Rejected materials. Metals rejected by engineering particle cement which has deteriorated or aggregates which have segregated or become contaminated shall be immediately removed from site. Records. Contractor shall maintain on site for records of all work carried accurately. The related location of work on site which shall include time and date when all concrete or support formwork removed and when formwork props were fully removed. All cubes and other tests. Daily maximum minimum temperatures. One copy of test shall be sent to engineer immediately upon completion of test. Now this is table we refer to last one. Sampling procedures and minimum sample size for sample materials laboratory. Cement, full range of tests, composite samples of 7 kg taken from at least 12 bags. Then aggregates, full range of tests 200 kg. We have to do in that full range, that means sieve analysis we have to do, chemical analysis, soundness test, water absorption, particle density, flakiness index, fines content, Los Angeles aberration value for this 50 kg. There is a reinforcement tensile test 500 mm, length bend test 300 mm. Then we say water full range test, that's 5 liters. It's according to table 1, now table 1, 2. Minimum testing equipment for each site. Test equipment to provide minimum required. Now, slump test BSEN 123502 or GSO IS 19202 or ASTMC 143. Slump cone with base plate 1, compacting rod, circular cross section at round ends 1, and remixing container 300 mm ruler moist cloth 1, scoop and shovel, etc. etc. Cube making BSEN 12390-1 and BSEN 12350-1 or GSO IS 19200 or whatever it is. 100 or 1M50 cubical or cylindrical molds, 6 numbers, compacting rod or bar set of tools or assembling a strip of molds, 1 number, remixing container 1 number, trowel, scoop, shovel and mallet, mold reagent and closed container with brush 1. Then it's a cube curing BSEN 123902 and whatever else the ISO and ASTM you can read yourself. Asian or stacking improvised shaped lot, maximum minimum thermometer 1, waterproof marking crayon paint or equivalent 1, curing tank in air conditioned room 1, supply of packing materials for sending cubes to commercial laboratory lot, concrete thermometer 1. The use of aluminum cubes and cylindrical molds are permitted when nominal maximum aggregate size is not greater than 20 mm. And this now come on to next one, and that is aggregates. Aggregates means general scope reference, definition, source approval, sampling, quality and testing, storage at contract plant, fine aggregate for concrete mortar, coarse aggregate for concrete, combined aggregate for concrete, washing and processing lightweight aggregate, coarse recycled aggregate. Now we're going to aggregates. Now general part covers requirements of aggregates for use in structural concrete. Related sections of parts are as follows. Part 3 cement materials, part 4 water, part 6 property requirements, part 7 concrete plants, part 8 transportation and planning of concrete, part 5 hot weather concreting, part 17 structural precast concreting, part 8 pre-stress concreting. All these are interlinked together with this part, and that's aggregate because it's all related to that one. Our references are ASTM, let's say numbers here you can read yourself, standard specification concrete aggregates, other one test method for organic impurities of fine aggregates of concrete, one is ASTM C33, ASTM C40, ASTM C88, test method for soundness for aggregate use of sodium sulfate or magnesium sulfate, ASTM C123, test method of lightweight pieces in aggregate, ASTM C127, test method of specific gravity and absorption of coarse aggregate, ASTM C128 test method of specific gravity and absorption of fine aggregate, ASTM C131 test method for resistance to degradation of small size aggregate by aberration impact and losses of machine, ASTM C130 standard test method for C analysis of fine and coarse aggregate, ASTM C140 test method for clay lumps and friable particles and aggregates, ASTM C535 test method for resistance to degradation of large size coarse aggregate by aberration and impact in Los Angeles machine, ASTM C702 is standard practice for producing samples of aggregate and testing size, ASTM D75 standard practice for sampling aggregate, BRA Digest 332 alkali silica reaction in concrete, detailed guidance for new construction, DS933-3 Test for geometrical properties of aggregates. Determination of particle size. Flakiness index. Flakiness index. Very important point. BS 9337. Test for geometrical properties of aggregate. Determination of shell content. Percentages of shell in coarse aggregate. 9399 is BS test. Geometrical properties of aggregate. Assessment of fine methylene blue test. BS 93311 test for geometrical properties of aggregate. Classification test for constituents of coarse recycled aggregate. And BS 10976 test for mechanical and physical properties of aggregates. Determination of particle density and water absorption. BS 8500 Part 2 concrete complementary release standard of BS EN 2061 specifics for constituent metals and concrete. BS EN 12620 aggregates for concrete. BS EN 17441 test for chemical products of concrete. Chemical analysis. BS EN 174-5 test for chemical products of aggregate. Determination of acid soluble chloride salts. BSEN 1367-2 test for thermal and weathering properties of aggregate. Magnesium sulfur test. BSEN 1367 for determination of drying shrinkage. BSEN 933 test for geometrical properties of aggregate. BSEN 1097-2 test for mechanical and physical properties of aggregate. Methods for determination of resistance to fragmentation. BSEN 10967-176 test for mechanical and physical properties of aggregate. Determination of particle density and water absorption. BA 73055 lightweight aggregate light breaker for a concrete motor and grout. BSPD 6S80 published document means BS published document PD 6S82-1 aggregate for concrete guidance to use of BSEN 12620. BSPD 6S82- for aggregate lightweight aggregate for concrete motor and grout aggregates use of BSEN 13005. AN 13139 aggregate for mortar. EN 19981 specification of mortar for masonry, rendering and plastering mortar. Rendering and plastering, remember, rendering is external plastering and plastering is internal plaster. EN 19982 specification for mortar for masonry mortar. ISO 9001-2008 was now revised quality management system requirements, so it's now 2015. ISO 170 with general requirements for competence of testing and calibration laboratory. 170 IRL recommended test for AAR1 detection of potential alkali reactive aggregates, petrographic method. RINM AR2 recommended test for AR3 detection of potential alkali 38-degree test method for aggregate combinations using concrete prisms. Now, aggregate granular material used in construction and may be natural, manufactured or recycled. Natural aggregate from mineral sources which has been subject to nothing more than mechanical processing. Manufactured aggregate of mineral origin resulting from an industrial process involving thermal or other modifications. Recycled aggregate resulting from processing of inorganic material previously used in construction. Lightweight aggregate of mineral origin having a particle density not exceeding 2000 kg per meter. That's lightweight aggregate. Aggregate of mineral origin having a particle density not exceeding 2000 kg per meter cube or a loose bulk density not exceeding 1200 kg per meter cube. Source approval. Source approval. Contractor shall use those imported materials sourced from an accredited quarry, producer or accredited supplier which have been approved by standards with the tar standards or their representatives. Accredited aggregate supplier shall provide source names for every shipment of aggregate delivered to concrete supplier. Source of metals may be changed by contractor during project provided that replacement material shall be sourced from an accredited quarry products and replacement materials are not significantly different in terms of physical and chemical properties, thus ensuring that resultant concrete continues to comply fully with a specified requirement. When considered whether an aggregate supplier or aggregates producers are suitable to be accredited, preference will be given to organizations with a proper quality management system, such as ISO 9001 or another quality management system approved by standards. When requested by engineer in charge, aggregate supplier shall provide a geotechnical analysis on, on rock samples before blasting and grinding to ensure proper quality of material. Aggregates shall be properly stocked and labeled without intermingling at whatever source area. When requested by engineer, aggregate supplier shall provide data for past 6 months that shows consistency of materials and conformity with this specification. Supplier shall verify compliance of aggregates per QCS by an independent qualified testing agency accredited to ISO 17025 and approved by Qatar standards. Sampling. Contractor shall provide samples of both fine and coarse aggregate to engineer in accordance with requirements of relevant standards in QCS for sampling reduction and testing of aggregates or testing at least 2 weeks before beginning deliveries to site. All samples shall be taken in presence of an engineer or an approved testing agency assigned by engineer. Aggregate sampling and tests shall be conducted by qualified staff. Quality and testing. Quality. Biggest question mark. Aggregate shall consist of tough, hard, durable, and uncoated particles containing no harmful material in quantities sufficient to adversely affect concrete or reinforcing steel, and shall contain no materials like to cause staining or otherwise disfigure concrete surface. Aggregate shall be obtained from a source approved by engineer. Aggregate shall meet requirement, which is table 2.1 that we have already discussed. Additional test detailed as BSEN 12620 with BSPD published documents 682 EN 1313 9 EN 998-1 EN 9982 all relevant ACI STEM standards and codes of practice may be required by engineer to satisfy certain requirements. Contractor shall provide all data as specified in QCS. Sampling of aggregate shall be carried out in accordance with the requirements of BSEN 13620, BSEN 933, ASTM D75, ASTM C702. Fine aggregate shall be natural sand or manufactured. Fine aggregate shall be natural sand or manufactured crushed rock sand. Crushed rock sand shall be direct product of a manufacturing process, not byproduct of coarse aggregate production. Bench Beach sand shall not be permitted for use in concrete mixes. Repeat, beach sand shall not be permitted in use in concrete mixes. Use of clean dune sand blended with coarser sand may be permitted, providing it can be shown that sand is free from contaminants. Use of local dune sand shall be prepared pre-approved by Ministry of Environment. Samples of aggregate shall be taken in accordance with requirements of Table 1.1, Part 1 we discussed already. Frequency of routine testing shall meet requirements as listed in Section 2. Frequency of testing may be increased by engineer's request if testing results show inconsistency, and frequency may be reduced if approved by engineer if materials are highly consistent. Mineralogical tests are to be carried out as instructed by engineer. No aggregate deliveries shall be made to site until engineer has approved samples as complying with this specification. Storage at contractor plant. Storage at contractor plant. Aggregate shall be stored as follows. Each nominal size of coarse aggregate and fine aggregate shall be kept separated and clearly labeled all times. Height of stockpiles shall be controlled to prevent harmful Segregation and breakage of aggregate. Stockpiles shall be on hard and grain surfaces with not more than 5% slope. 5% slope, mind it, it's not 45, it's 5% slope, which is for stockpiles. Hard and clean surfaces, hard and clean surfaces with not more than 5% slope for purpose of drainage, etc. Contamination of aggregates by ground or other foreign matter shall be effectively prevented at all times. Each heap of aggregate shall be capable of draining freely. Stockpiles shall be protected from direct sunlight or to shade them. Unloading of aggregate shall be controlled to prevent harmful segregation and breakage. Contractor shall maintain stockpiles of coarse aggregate in separate gradings. Separate gradings. Just a little, just a minute, please. Just a little tired because of my, all unloading of aggregate shall be controlled to prevent harmful suggestion and breakage. Contractor shall maintain stockpiles of coarse aggregate in separate gradings at construction site. Preparation, location and size of any stockpiles shall be approved by engineer. Table 2.1. Limits for physical, chemical and mechanical properties of aggregates for normal concrete. This is very important point. Limits for physical, chemical and mechanical properties of aggregates of normal concrete. Number, requirement, test method, permissible limits, BSCN, STN, fine scores. Grading, natural mean. Grading 933.1. Standard. Natural material finer than 0.063 mm. 933.1. 3% maximum. 2% maximum. Fine is 3% maximum. Coarse is 2% maximum. It is finer than 0.063. Crushed rock materials finer than 0.063 mm. 7% maximum. This is crushed rock and this was natural. There's a difference. So crushed rock is higher, permissible. 7% maximum in standards, fines and 2% maximum coarse. Fines quality structural concrete, sand equivalent percentages. So fine is 938, 60% minimum, 16% square. Then this is sand equivalent. Non-structural concrete, methylene blue adsorption, value 0 to mm, 933.9 BSCN and 1 gram per kilogram maximum. Clay lumps and friable particles, that is C142, this is ASTM, 2% maximum in both cases, fine and coarse. Lightweight pieces, C123, 0.5% maximum, 0.5% maximum. Organic impurities for fine aggregate, organic impurities C40, color standard not darker than plate number 3, Na not applicable, water absorption, saturated surface dry, 10976, 2.3% maximum, 2% maximum, particle density for normal weight concrete, 109,726, 2 minute, 2 minute, particle density for normal weight, 2 minimum, particle density, and shell content 933-7, this is EN, yes, EN, this is shell content 933.7, 3% max, 3% maximum. Flakiness index is very important point. 933 is now 35% maximum, but in 1985 it was 25%, so it is increased. Maybe due to some reasons or non-possibility, it was not possible to get 25%. I was there and it was 25% at that time maximum. It has always caused problems, so I think they are raised it to 35%, so it's okay, fine. Maybe it's difficult to get with 25% maximum. Before that was 15%. Acid soluble chlorides, not applicable, I think. Now reinforce, yes, it's there. And reinforce and mass concrete, is 0.06% max and 0.03% max. This is acid soluble chlorides. Pre-stressed concrete and steam cured structural concrete. It's autoclave, you can say, kind of autoclaving, 0.01% and 0.01%. Now, then it is aggregates again continuous, and we are saying acid soluble sulfate, 17.441, 0.4% maximum and 0.3% maximum. Soundness by magnesium sulfate, 5 cycles, 13672, 15% maximum and 15% maximum. Soundness by magnesium sulfate, 5 cycles. Resistance to fragmentation, Los Angeles aberration, 10972, 30% maximum. Drying shrinkage, 13674, 0.075% maximum. Drying shrinkage, 0.075% maximum. Potential activity, see note 6 below. We'll see what note says. We'll see how it is. Let us see. Now it says notes there. Use of BSEN or relevant GSO standards. This GSO stands for Gulf Standard Organization. If sand equivalent value is less than 60% and greater than or equal to 50%, sand shall be considered non-harmful and is accepted provided that methylene blue value is less than or equal to 1 gram per kilogram. Not required when fines content in fine aggregate or in all in aggregate is 3% or less. Organic impurities, use of a fine aggregate filling in test is not prohibited provided that organic impurities used in a fine aggregate filling in test is not prohibited provided that discoloration is due principally to presence of small quantities of coal, lignite or similar discrete particles. When tested for effect of organic impurities on strength of mortar, relative strength at 7 days, calculated in accordance with ASTM, C87 is not less than 95%. If chloride content is higher than 0.01%, Following steps may be taken. Aggregate may be washed by suitable water. Aggregate may be washed by suitable water before mixing to lower chloride content to specified value 0.01%. If washing process does not reduce chloride content to required value, acid soluble chloride content in concrete ingredients, sum of contributions from constituent materials shall be tested as mentioned in BS 85002. Allowable acid soluble chloride content limit shall not exceed values given in section 5 part 6 para 653. Now 6, we were talking the 6 here was regarding potential reactivity. Potential reactivity. Alkali aggregate reactivity shall be assessed at source in accordance with BS 2061 BS 8500 certification 2 BS 85002 certification shall be obtained from aggregate source indicating absence of deleterious expansion of concrete due to alkali aggregate reactivity. Fine aggregate for concrete and mortar. Fine aggregate. Fine aggregate consists of natural clean sand, stone screenings, natural clean sand. Stone screenings are a combination and can be produced from natural disintegration of rock or gravel and or by crushing of rock or gravel or processing of manufactured aggregate or artificial conforming to requirements of physical and chemical properties complying with table 2.1 we already discussed and subject to engineers acceptance. Crushing fine aggregates may be blended with local wash sand provided that fine aggregate complies with requirements of table 2.1 as discussed. Gradation of fine aggregate for concrete and mortar shall be in accordance with gradation designations in BS EN 12620 with BS PD 6682, EN 13139, EN 9981, EN 9982 are relevant ACI and ASTM standards and codes of practice and subject to engineers acceptance. Aggregates continue. Each batch of aggregate delivered to site shall be kept separate from previous batches and shall be stored to allow for inspection and tests to be carried out. Local natural sand shall be mechanically washed to remove salts and other impurities in order to meet specified requirements. Storage area for clean wash sand. Storage areas for clean wash sand shall be shaded from direct rays of sun and shall be screened for protection from dust. Area in neighborhood of stockpile mixing area in neighborhood of stockpile area in neighborhood of stockpile mixing plant shall be watered as necessary to reduce rising of dust. Uses of dune sand shall be accepted as governed by regulation of Qatar Ministry of Environment and shall be not used for any reinforced concrete. Uses of dune sand shall be accepted as governed by regulation of Qatar Ministry of Environment shall not be used for any reinforced concrete, used only for blocks, block mortar, plasters, soil cement, shotcrete and insulation concrete. Coarse aggregate for concrete. Coarse aggregate is granular material and may be natural, manufactured, recycled or a combination of all. It shall flow from deleterious matter and conforming to requirements of physical and chemical properties per table 2.1 as a minimum requirements and subject to engineer's acceptance it BSCN 12620, BSPD 6682 or ASTM C33. For imported aggregate, Qatar standards may publish more requirements and stringent limits than specified in Table 2.1. For other types of concrete mixes and subject to engineer's acceptance, coarse aggregate shall comply with relevant BSEN or relevant ACI or ASTM standards and codes. Nominal mixes size of coarse aggregate shall be not larger than number way 1/5 of narrowest dimension between sides of forms. 1/5 narrowest dimensions between sides of form. B. 1/3 depth of slab, nor C. 3/4 minimum clear spacing between individual reinforcing bars or wires, bundles of bars, individual tendons, bundle tendons or ducts. These limitations shall not apply if in judgment of licensed design professional. These limitations shall not apply if in judgment of licensed design professional workability workability and methods of consolidation are such that concrete can be placed without honeycombs or voids as requested by engineer. Contractor shall mechanically wash aggregates to remove salts and other impurities in order to meet requirements specified. Combined aggregate for concrete. Materials passing 0.063 mm sieve shall not exceed 3% of combined aggregate. By weight, combined aggregate gradation used in work shall be as specified, except when otherwise approved or directed by engineer. Changes in approved gradation shall not be made during progress of work unless approved or directed by engineer. Washing and processing. Where aggregates have been washed shortly before delivery to site or if stockpiles have been sprayed to cool them, samples of aggregate shall be taken frequently to determine correct amount of water to add to mix. Lightweight aggregate. Lightweight aggregates are those having particle densities not exceeding 2000 kg per meter cube or bulk density not exceeding 1200 kg per meter cube. Lightweight aggregate include natural aggregate manufactured from natural materials and or a byproduct of industrial process and some recycled aggregate. Lightweight aggregate shall be in accordance with BSEN 1305151 and BSPD 66824 or equivalent ASTM standards. Coarse recycled aggregate. Excavation waste EW, coarse recycled aggregate RA and coarse recycled concrete aggregate RCA, that is coarse recycled concrete aggregate. So EW stands for excavation waste, RA stands for recycled aggregate and RCA stands for coarse recycled concrete aggregate. Shall meet with requirements in table 2.1 with the exception that water absorption shall not exceed 3% for structural concrete, 4% for non-structural concrete. For structural concrete, EW, excavated material, as we said, EW, you know this, excavation waste, and RCA may be used in design concrete of maximum C30. Its proportion shall be not more than mass fraction of 20% of coarse aggregate BS 85002 section 622 except where approved by Qatar standards, to use a higher proportion. For non-structural concrete, such as crash barriers and soakways, EW and RCA may be used in designated concrete of maximum C40. Its proportion shall be not more than a mass fraction of 50% of coarse aggregate BS 85002 section 622 except where approved by Qatar standards to use a higher proportion. For non-structural concrete, RA may be used in designated concrete of maximum C25. Its proportion shall be not more than a mass fraction of 20% of coarse aggregate BS 85002 section 622 except where approved by Qatar standards to use a higher proportion. This is for non-structural concrete where RA may be used in designated concrete of maximum C25 proportion. Its proportion shall not be more than a mass fraction of 20% of coarse aggregate except where approved by standards. When composition of coarse RCA and coarse RA is tested in accordance with BSEN 93311, test result obtained for each type of particle shall not exceed maximum value specified in table 22. EW aggregate shall meet same requirements for RCA as given in table 22. Table 22. Let us see what is this table 22, because this is important table. We have to understand accordingly. It's not simply reading this table to understand, because there is requirements for coarse RCA and coarse RA mass fraction percentage. Type of aggregate, maximum masonry content, maximum fines, maximum lightweight materials, maximum asphalt, maximum foreign material, namely glass, plastic, metals, maximum acid soluble sulfate SO3. RCA, maximum masonry content 5, that is 5, right? That is requirement is 5. Mass fraction is percentage. Maximum fines 5. Maximum lightweight material 0.5. Maximum asphalt 5. Foreign materials glass, plastic, metals 1. Maximum acid soluble sulfate SO3 1. RA, maximum masonry content 100. Maximum fines 3. Maximum lightweight material 1. Maximum asphalt 10. Foreign materials glass, plastics, metal, etc. This is 1. Maximum acid sulfate. Now, where material to be used is obtained by crushing hardened concrete. Where material to be used is obtained by crushing hardened concrete of known composition that has not been in use, namely surplus precast units or returned fresh concrete, and not contaminated during storage or processing. Only requirement are those for grading and maximum fines. Material with a density less than 1000 kg per meter cube. Provisions for coarse RCA may be applied to mixtures of natural coarse aggregates blended with listed constituents. Appropriate limit and test methods need be determined on a case-by-case basis. Note 6 to 4.3 BS 850 is now floating material, that is FL. Floating material content per BSEN 93311 shall not exceed 5 cm cube per kilogram. RCA should be treated as highly reactive aggregate. Alkali contribution from RCA shall be determined as given in BS 85002. For manufacturing of masonry concrete block, use of recycled aggregate is permitted up to 100% in accordance with ACI 555. Now we go to cementitious material. Cementitious material. In this case, we have journal, that is scope, reference, terms on definitions, source approval, sampling, quality and testing, delivery, storage and handling. And we have here cementitious materials scope. Part covers requirements for testing and use of cement in structural concrete. Property requirements are what relevant sections are. This is I meant to say Part 6 of property requirements, and now references are ASTM C10 standard specification for natural cement, ASTM C91 specifications for masonry cement, C114 test methods for chemical analysis of hydraulic cement, ASTM C115 test method for fineness of Portland cement by turbidimeter, that is test method of fineness of Portland cement by turbidimeter. C150 standard specification for Portland cement, C183 standard practice for sampling and amount of testing of hydraulic cement, C188 test method for density of hydraulic cement. When I am saying ASTM is included with that, C186 test method for heat of hydration of hydraulic cement, C204 test method for fineness of hydraulic cement by air permeability, C348 test method for fractural strength of hydraulic cement mortar, C349 test method for compressive strength of hydraulic cement mortar using portion of prism broken in fracture, C430 test method for fineness of hydraulic cement by 45 mm, that is number 3 to 5. C59 standard specification for blended hydraulic cement, C618 standard specification for coal, fly ash and raw calcined natural pozzolana for use in concrete, C845 specification for expensive hydraulic cement, C989 standard specification for slag for use in concrete and mortars, C1157 standard performance specification for hydraulic cement, C1240 standard specification for silica fumes used in cementitious mixtures, C1328 specification for plastic cement stucco, and C1329 specification for mortar cement. Now British standards, BS146 Portland blast furnace slag cement, Portland blast furnace cement, 1370 BS1370 low heat Portland cement, BS4027 sulfate resisting Portland cement, BSCN 196 methods for testing cement, BSCN 1971 cement composition specifications and conformity criteria for common cements, BSCN 1974 cement composition specifications and conformity criteria for low early strength blast furnace cement. Terms and definitions. Cement teaches metals after water gas. Portland cement in combination with one or more of following blended hydraulic cement, fly ash or other pozzolanas, ground, granulated, blast furnace slag, silica fume, and metakaolin. Metakaolin, you know where it is. We have understood that in clay section. Subject to compliance with requirements of this specification. PC shall be in Portland cement or CEM1, FA or PFA shall be in fly ash or pulverized fuel ash. GGBS shall mean ground granulated blast furnace slag. Source approval. Still, I'm trying to give something because better to give, otherwise, I'm very sick. I'm in bed, bedridden, just for information. Maybe for a couple of months, I'll remain bedridden due to accident. So, excuse me if I'm not able to raise my voice because of fatigue I got in. Well, still I'm trying to pass information to you which I passed long back, but now renewal is better. Contractor shall submit to engineer for approval full details of proposed source of cement. These source of cement supply shall be regularly and thoroughly investigated to ensure that quality of material supply is satisfactory and that it does not deteriorate during performance of project. Cement source shall not be changed without engineer's acceptance. Contractor shall supply engineer with manufacturer's test certificates certifying that cement is in compliance with relevant standards. For imported cement, manufacturer's test certificates shall be provided with each consignment. Contractor shall submit to engineer date of manufacture and proof that the specifications have been complied with, certified by an independent agency in country of origin. Cement manufacturers shall label their packagings and delivery documents and provide where applicable information on packing, dispatch date, storage conditions and storage period appropriate to maintaining activity of reducing agent and to keep content of soluble chromium below 2 ppm limit, soluble chromium 6 below 2 ppm limit. Engineer has right to test cement for presence of chromium at contractor's expense. Sampling. Methods of obtaining samples of cement for testing shall be carried out per description in AN 196 or ASTM 183. Quality and testing. Cementitious material shall fully comply with relevant standards from following list. Standard specification for Portland cement C150, C595, when I'm saying C means ASTM it is, C595, standard specification for blended hydraulic cement. C618, standard specification for coal, fly ash and raw natural pozzolana for use in concrete. C989, standard specification for ground granulated blast furnace slag for use in concrete and mortars. ASTM C1157, standard performance specification for hydraulic cement. C1240, standard specification for silica fumes used in cementitious mixtures. BS146, Portland blast furnace cement. 1370, low heat Portland cement. BS4027, sulfate resistant Portland cement. 19E BSEN 1971, minimum grade 42.5. BSEN 450, fly ash for concrete. BSEN 15167, ground granulated blast furnace slag for use in concrete, mortar and grouts. EN 12363, silica fumes for concrete. Relevant GSO, that is Gulf Standards Organization. Water soluble chromium content shall not exceed 2 ppm at 0.0002% by total dry weight of cementitious material. तो पानी है क्या पीने का? दो प्यास खुश्क हो रही है. Delivery, storage and handling. Cement shall be delivered to site in sealed and branded bags or in manufacturer's containers, bearing manufacturer's name, cement type and date of manufacture in batches not exceeding 100 tons. Cement shall be stored at site in such a manner as to prevent its deterioration, intrusion of moisture and foreign matter. बन रही है तो कम पीओ ना. Cement shall be stored at site in such a manner as to prevent its deterioration. Note these points. To prevent deterioration, intrusion of moisture and foreign matter. It must be kept dry all times. Immediately upon arrival at site, contractor shall store cement in bins or silos designed for purpose. It shall be tight and provide for free movement to discharge opening or be dry weather tight and properly ventilated structures with floors raised a minimum of 450 mm above ground with adequate provisions to prevent absorption of moisture. I have seen many sites, unfortunately, such stores are not sealed and people do not bother, even quality people do not bother that cement bags are set. Unfortunately, this is no water. Air enters this storage and which carries moisture with that, which makes cement set and nobody bothers. They waste cement, they waste material, waste money and do not care for air tightness of stores. Unfortunately, all storage facilities shall be subject to approval of engineer and shall be such as permit easy access for inspection and identification. Prolonged storage of cement at site is to be avoided. Means you should use it as soon as possible rather than keeping it stored for long time. Is not recommended. For bagged cement, each consignment of cement shall be kept separately and contractor shall use a consignment in order which they are received. Contractor shall keep records of various consignments. Contractor, when I say contractor, this is a professional contractor who is expert on construction. Contractor shall keep records of various consignments of cement in store, giving quantities received and used and sections of work in which cement has been used on a daily basis and make a weekly return to engineer accordingly. Cement used in work shall be free flowing and free from rust. Free flowing and free from lumps. This is very important. I repeat, contractors shall keep records of various consignments of cement in store, giving quantities received and used and sections of work in which cement has been used on a daily basis and make a weekly return submitted to engineer accordingly. Cement used in works shall be free flowing and free from lumps. This is very important part of quality control system, quality management system. If cement is rubbishly used, then everything is rubbishly done. In no case shall bagged cement be stored in stacks more than 8 bags high. Now, a free passage of at least 1 meter shall be left between cement and side walls of structures. 1 meter clear passage is a must. Different types of cement shall be kept in clearly marked separate storage facilities. Cement delivered to site in drums or bags by supplier or manufacturer shall be stored in drums or bags until used in works. Cement in drums or bags have been opened shall be used immediately. Cement that has been partially or fully caked in storage will not be permitted in work and shall be immediately removed from storage area. Whatever bag or package or sample of cement which has been damaged or rebagged in or in whatever way has deteriorated shall be rejected either as an individual bag or package or as whole consignment in which such bag, package or sample is contained as advised by engineering charge. Where site limitations preclude storage of cement on site, cement shall be stored at a central location and shall be delivered daily as required to specific job sites. Contractor shall provide weighing machines which be kept permanently in each shed for checking weight of bags or barrels in cement. Weighing machines shall be calibrated by independent agency. Engineers shall have access all times to cement storage sheds. During transport and storage, cement shall be fully protected from all weather elements. Consignment of cement not used whatsoever within 2 months from date of manufacture, and cement which in opinion of engineer is of doubtful quality shall not be used in works until it has been retested and test result shades showing that it complies in all respects with the specification and relevant standards have been delivered to engineer. Cement stored for longer than 28 days shall be tested for loss on ignition prior to use, check for deterioration, and whatever cement which fails test shall not be used in works. Water. Water. Very important part, water. Scope, reference, quality of water, which is general, pH of water, permissible temperature, supply and storage, testing and sampling, health and safety. Water. Now water. This part includes water used for concrete mixtures, washing of aggregates and equipment, wetting of surface or ponding during curing, or for wetting formwork and washing reinforcement. Related sections and parts are as follows. Part 2 aggregate, Part 6 property requirements, Part 9 formwork, Part 10 curing, Part 11 reinforcement. References are ASTM C109, test method for compressive strength of hydraulic cement mortars using 2 in of 50 mm³ specimen, BS1377 methods of test for soils for civil engineering purpose, BS2690 methods of test water used in industry, BS6068 water quality, BSEN ISO 99631 determination of total and composite alkalinity, BSEN 1 ISO 99632 determination of carbonate alkalinity, EN1961 determination of strength. EN1962 methods of testing semen. Part chemical analysis of semen. EN1963 determination of setting time and soundness. EN1008 mixing water for concrete, specification for sampling, testing and assessing suitability of water, including water recovered from processes in concrete industry as a mixing water for concrete. SM520-5220B chemical oxygen demand. SM4500 standard methods for examination of water and wastewater. ISO 7890 water quality determination of nitrate. Part 1 is to 6 D dimethyl-phenol spectrometric method. 6 is dimethyl-phenol spectrometric method. SM3125 BICP1S methods by inductively coupled plasma mass spectrometry. Quality of water. Quality of water. Potable water is suitable for use in concrete, while water of other origin, such as underground water, natural surface water, recovered water, as well as municipal treated water or mixed water, shall be tested to prove that its quality shall conform to water quality requirements as given below in 4.3. On site where a permit is issued for municipal treated effluent use for concrete, effluent shall be treated by tertiary treatment stage, reverse osmosis RO, and disinfection, ultraviolet radiation, or ozonation. Water shall be examined in accordance with test procedures stated in Table 1 EN 1008. Water not conforming to one or more of requirements in Table 1 EN 1008 may be used only if it can be shown to be suitable for use in concrete in accordance with physical tests of Table 1 below. Site health and safety services and treaty effluent quality shall fulfill requirements of 5. pH of water. pH of water used in concrete work shall be as shown in Table 4.2. Permissible temperature. Temperature of water for concrete shall not be less than 5. Important point. Temperature of water for concrete shall not be less than 5 degrees Celsius and not more than 40 degrees Celsius. This point is very important. Temperature of water for concrete shall not be less than 5 degrees. Means you cannot do in January, for example, in this country, Bharat, India, and not more than 40 degrees Celsius, means you cannot do in hot weather conditions. Water may be cooled to not less than 5 degrees Celsius by gradual addition of chilled water or ice as follows. No ice particles shall be present in mix. Alternatively, flaked ice may be used. Ice to be used shall be crushed and shall be product of frozen water, which complies with acceptance criteria of tables 4.1, 4.2 and 4.3. Every effort should be made to protect water pipes and tanks from sun. Protection from sun, that is burning, shedding, insulation or painting white. Supply and storage. Contractors shall make own arrangements and obtain approval of engineer for supply of water. Storage of water should be such that contamination is prevented from occurring. Whatever measures taken to avoid contamination of water shall be to approval of engineer. Testing and sampling. Whenever required to do so by an engineer, contractor shall take samples of water being used or which is proposed to use for mixing concrete and testing them for quality. Samples of water not less than 51 shall be taken. Samples of water of not than 51 shall be taken, sealed and sent for testing. That doesn't mean I don't know what is 51. 5 liter, I'm sorry, is not 51. I don't know what's the print mistake. Samples of water less than 5 liters shall be taken, sealed and sent for testing at an approved laboratory, independent laboratory, prior to approval of whatever water source. And whenever source of water is changed periodically during continuance of its use. Water of questionable quality should comply with physical tests of table 4.1. क्या no source of water, water of questionable quality, water of questionable quality should comply with physical tests of table 4.1 and chemical limitations listed in table 4.2 and table 4.3. No source of water shall be used until required tests have demonstrated their suitability for concreting. Use of water from a municipal or government supply does not preclude requirement for testing. Acceptance criteria for table 4.1. Table 4.1 acceptance criteria and physical tests for mixing water. Compressive strength of 7-day minimum percentage of control EN 1961, limit 90%, setting time maximum deviation from control hour minute EN 19639 from 1 early to 1:30 late. Table 4.2 chemical limitation for mixing water. Chemical limitations. Parameter test method maximum limit milligram per liter. Chloride HCl test method is BS6068137 ISO 9297. Now A1 for pre-test concrete maximum milligram per liter is this for chlorides 500, for pre-test concrete 500 milligram per liter. For reinforced concrete 1000, that is 1000 milligram per liter. For concrete without reinforcement, 4500. Concrete without reinforcement means plain concrete. You can say blinding concrete, or you may say some other concrete where no reinforcement is used. So these are limits. So minimum allowance is for pre-stressed concrete, which is 500 milligram per liter chloride. Then for reinforcement concrete, which is 1000 milligram per liter chloride content. And for concrete without reinforcement, blinding, which is or mass fill, you can say 4500 milligram per liter chlorides. Now sulfates. SO4 is students En91962, that is 2000 milligram per liter. Alkali BS60682-2.51, which is alkali carbonates and bicarbonates, 500 milligram per liter. It's alkali carbonate and bicarbonate BSEN ISO 9963-1, BSOEN ISO 9963-2, so 500 milligram per liter. And alkali equivalent sodium oxides, that's En1962-1500 milligram per liter. Now, total dissolved ions, including A, B, and C above. Total dissolved ions, BS1377 part 3. For pre-stressed concrete, 1000 milligram per liter. Total dissolved ions, and for reinforced concrete, 2000 milligram per liter. Dissolved ions, and for concrete without reinforcement, 5000 milligram per liter. pH BS60682-2.50, 6.529, that's pH. Table 4.3, maximum limit of harmful contaminants. Oh, I'm sorry, I'm taking just finish buying some cup of tea. I hope you may not be enjoying, but you are enjoying, I think. It's a very much technical document, and it's very important document as far as I understand from virtual and practical viewpoint. If you want to improve your knowledge of concrete and apply that in field, I think it's a better opportunity for everybody to go through this document. Though it may not be very useful, but it can get you much more than what you get from our course in this country. When I worked in Qatar in 1985 to 89, or later in 2000, in 1996 as well, I did not find this detailed specification of Qatar Qatar concrete. Now it's much more and maybe more revised later. This is 2014. It's good one to enhance knowledge because as much as knowledge you have, you can apply on quality system, and application is very important rather than just going to this paper. There is no need to remember all this what I am telling or reading, just to understand that. Apply them as much as possible. Examples, temperature of water, temperature of concrete, how you control that. All these are very important points. Now see, parameter COD, that is SM5220 maximum, if it is milligram per liter. Chemical oxygen demand and phosphate expressed PO4 is SM 4500 PB, CSM 4500 PD by subtraction. So you can say 30 milligram per liter. Nitrate expressed as NO3 and ISO 7890100. Lead expressed as PB2 plus and SM3125B. ICPM is 100 milligram per liter. Zinc expressed as Zn2 SM3125 100 milligram per liter. Standard methods, SM stands for examination of water and wastewater. Now, health and safety is very important part in this. Health and safety. Without health and safety, we cannot work as engineers. First is safety, then is work. If we are not safe, we are not healthy, there is no way that construction can be moved. You cannot move construction if people are not safe, people are not healthy, you are not healthy, workers are not healthy, and you may say our complete environment of site is not healthy. There is no meaning in moving. On site, where permit is issued for municipal treated water use in construction works, effluent should be treated by tertiary treatment stage, as we discussed before, including filtration and disinfectant, chlorine alone, or ultraviolet radiations or ozone application. Furthermore, following site health and safety services and treated effluent quality must be fulfilled. Residual chlorine level shall be within range of 0.5 to 1 milligram per liter. For water to be used for concrete, disinfectant shall be ultraviolet radiation or ozone application. For water to be used for concrete, disinfectant shall be ultraviolet radiation or ozone application. Coliform level shall fulfill one of following: fecal coliform less than 200 CFU per 100 milliliter in case there is no direct exposure on site labor. Total coliform less than 23 CFU per 100 milliliter in case there is direct exposure on site labor. I am calling labor, which is but I call them workforce. Sites shall be facilitated by health and safety guidelines, signs, where it's indicated by Arabic, English, and whatever other languages where there are 5 workers or more on site. The water not for human consumption must be noted. Sites shall be facilitated by health and safety equipment as well as personal health and safety protection equipment. Labor or workers shall follow health and safety guidelines and instructions and use their health and safety personal protection equipment. Admixtures. Now, admixtures very important part. Scope, references, definitions, submittals. Use of admixture, general trials, waterproofing admixtures, general water resisting admixtures, permeability reducing admixtures, submittals, general organic corrosion inhibitors, organic corrosion inhibitors, inorganic corrosion inhibitors. Admixtures general. Now, linked sections are general, then property requirements, then concrete plants, miscellaneous, and codes are ACI 2123R10 report on chemical admixture for concrete, ACI 302 guide for concrete floor and slab construction, ACI 305 hot weather concreting, ACI 308 standard practice for curing of concrete, AS3 ASTM C9 C494 standard specification for chemical admixture for concrete, ASTM C1582 standard specification for admixtures to inhibit chloride induced corrosion of reinforcing steel in concrete, BSEN 934 admixture for concrete, mortar and grout parts 2 6, BSEN 196 methods of testing cement, BSEN 14889 fibers for concrete polymer fibers, definitions, specifications and conformity, NSF standard 61 definitions. Now, admixtures are materials added during mixing process of concrete to modify properties of concrete mix in fresh and or hardened state. Submittals In addition to specified general requirements for approval of materials, approval of admixtures shall be subject to extensive trials to demonstrate suitability, adequacy of dosing, arrangements, and performance. Use of admixtures. Admixtures are materials added to concrete materials during mixing process to modify properties in fresh or in hardened state. Where approved and directed by engineer, admixtures shall be used as a means of A. Enhancing concrete durability, increasing workability of concrete without increasing water cement ratio, controlling retardation and setting time. So what are these? Enhancing concrete durability is number one, which is very important. Durability, very important property of concrete. Durability is included in reliability, and reliability is equal to reliability means safety plus serviceability plus durability. So durability is integrated within reliability itself. And second one is increasing workability of concrete without increasing water cement ratio, which is for fresh concrete. And the best way is how to lay concrete without any problems, without any segregation. Controlling retardation and setting time. Retardation and setting time. Okay, so these are major factors. Now, admixture shall comply with following BSCN 934 requirements or equivalent ASTM-C 494. Water reducing or plasticizing admixture. Water reducing and plasticizing admixtures where concrete becomes more fluid and without addition of water, that is, and can be pumped well. Pumping is very important activity in modern world. Pumping is pumping by mobile application or pumping by different way for high-rise structures where pumps cannot reach, mobile pumps cannot reach, where just like for example, World Tower or you can say Burj Khalifa, there's an experiment conducted for this how to pump it. So they designed something added plasticizer and conductor experiences. So high range water reducing plasticizing admixture. High range water reducing, you have to reduce quantity of water at high level. And set retarding mixtures. So set retarding mixtures. Now, methods and quantities of admixture used shall be in accordance with manufacturer's instruction and subject to engineer's approval after evaluation in trial mixes and shall in no way limit contractor's obligation under contract to produce concrete with specified strength, workability, and durability. This means ultimate responsibility despite approval by engineer and approval by authorities, ultimate responsibility is owned by contractor who is responsible to deliver concrete with specified strength, workability and durability. Engineer's approval shall not come in any way. It's only for supporting work. So we have to understand this point very well legally, contractually in all respect. You cannot say because engineer is approved, contract is not responsible. Internationally, for contractors to help. Methods and quantities of admixtures used shall be in accordance with manufacturer's instruction and subject to engineer's approval after evaluation and trial mixes and shall in no way limit contractor's obligations under contract to produce concrete with specified strength, workability and durability. Engineers should be clear with this provision very well because misunderstanding must go. Contractor is ultimately responsible means contractor is professional contractor, not a street vendor. Effects of accidental overdose of admixture and measure to be taken if an overdose occurs shall be provided by contractor to engineer. No admixtures containing chlorides. No admixtures containing chlorides shall be used. Remember, chlorides are not permitted because chlorides result in corrosion. In particular, use of acceleration admixtures containing calcium chloride shall not be used. Use of admixtures shall be controlled, that is, strict quality control, to ensure correct doses as prescribed by manufacturers and justified by trial mixes be used. A calibrated dispenser or flow meter shall be used for addition of admixtures. Trials. In addition to standard requirements for approval of materials, approval of admixtures shall be subject to extensive trials to demonstrate suitability, adequacy of dosing, arrangements and performance when a proven history of performance cannot be provided to satisfaction of engineer. Waterproofing admixtures. General. Admixtures shall be suitable for use in Gulf condition and especially formulated for higher ambient temperatures. So Gulf conditions and our conditions are no major differences because we have all seasons here in our country. We have hot which is up to 50 degrees in some cases. We have cold which is up to 0 degrees. In Iraq, for example, there was 0 degrees. So we can say it's not major difference. Yes, of course, rain is heavy here. That's only difference. So we have to apply this application, this specification to part extent, but understand everything. Admixture shall be added per manufacturer's data sheet. Approved third-party laboratory verification shall be conducted prior to use of material for products. Manufacturer's technical representative shall be present to ensure proper dosages of admixture during trial mix. Water resisting admixtures. Water resisting admixtures may be used. Water resisting admixtures may be used with permission of engineer and shall comply with requirements of BS EN 9342. Admixture is to be added per manufacturer's supplying data sheet at time of mixing. Approved lab verification shall be made prior to use. Permeability reducing admixtures. Permeability reducing is very important point. If you reduce permeability, concrete is better because it doesn't allow water to move in. Permeability, higher permeability means weak concrete, and minimum permeability, lowest permeability level is good concrete, which can go for long, which is durable one. Admixture shall be permeability reducing admixture. Permeability reducing admixture for non-hydrostatic conditions. Non-hydrostatic conditions, PRAN. And for hydrostatic conditions, PRAH. PRAN is non-hydrostatic and PRH is hydrostatic conditions, as indicated by ACI 212-3R10 or crystalline waterproofing admixture. For PRH, independent testing laboratory shall be performed. For PRH, independent testing shall be performed according to NSF Standard 61, and approval for use of waterproofing material on structures holding potable water shall be evidenced by NSF certification. Submittals. Contractor shall submit. Contractor shall submit manufacturer's specifications, installation instructions, and other data to show compliance with requirements of this part of specification and contract documents Contractor shall submit comprehensive test results for waterproofing admixture as admixtures per test in specifications and evidence of their ability to meet all requirements in specified. Contractor shall submit a guarantee for waterproofing admixture. Guarantee shall be worded to reflect required performance of material and shall be approved by engineer. Corrosion inhibiting admixtures. Corrosion inhibiting genre. Where reinforced concrete structures are exposed to aggregates environments such as underground and marine structures, use of corrosion inhibiting admixture shall be used. Corrosion inhibiting admixture shall comply with ASTM 7582 standard specifications for admixture to inhibit chloride induced corrosion of reinforcing steel in concrete. Organic corrosion inhibitors. This is organic corrosion. Admixture shall be based on either aqueous emulsion of amines and esters or amine carboxylates and shall be capable of forming a protective corrosion resistant film around steel reinforcement. Organic corrosion inhibitor admixture shall be based on either aqueous emulsion of amines and esters or amine carboxylates and shall be capable to form a protective corrosion resistant film around steel reinforcement. Corrosion inhibitors shall be capable of effecting protection to steel where concrete has cracked and allows access to elements responsible for corrosion. Means this corrosion inhibitor shall be capable to effect protection to steel where concrete has cracked and allows access to elements responsible for corrosion. Organic corrosion inhibitors have a fixed dosage rate independent of chloride levels and shall be incorporated at dosage rate recommended and tested by manufacturer. Inorganic corrosion inhibitors. Inorganic corrosion inhibitors shall be based on calcium nitrite. Very important point. Inorganic corrosion inhibitor is very important. Practically, it's done in piling particularly. Inorganic corrosion inhibitors shall be based on calcium nitrides capable of oxidizing steel, be more stable form, increasing its passivity in presence of chlorides. Doses of inorganic corrosion inhibitors range from 10 to 30 liters per meter cube depending on expected chloride levels defined by ACI 212 table 13. So 10 to 30 liters per meter cube concrete. So 10 is minimum. Minimum is standard. Calcium nitrite we have to add in piling particularly or can be added to foundations also. So now property requirements are important point. Let us see how long it is. 143. Let's say I'm not very strong today because of sickness, so I'll just take few minutes more. Property requirements, and that is general scope, references, definitions, submittals, exposure classes, general reinforcement concrete and sulfate classes, fresh concrete, general grades of concrete, durability requirements, general maximum acid solution, soluble chloride content, type of cementitious materials, resistance to alkali silica reaction, recommendations to resist reinforced concrete, reinforcement corrosion, recommendations to resist reinforcement corrosion, recommendations to resist sulfate attack, durability related properties, design of concrete mixes, concrete trial mixes, quality and testing, general tests for concrete, hardened tests for fiber reinforced concrete, quality control charts, works test cubes, rejection of concrete mixes, unsatisfactory concrete works. So this is a very long one. Yeah. Let's see how many more pages can I take in few minutes. This part includes grades 15 MPa. This part includes grades 15 MPa and above. Concrete to be used in civil works. The requirements for workability, permeability, and drying shrinkage. So there are three properties mentioned here: workability, permeability, and drying shrinkage are three important ones. Part 2 is linked to this one, aggregates. So what's linked is aggregates, cementitious materials, water and mixtures, concrete plants, transportation and placing concrete formwork, inspection and testing of hardened roads, all are linked to concrete. So we move like this. Now I think the ACI 2071 our guide to mass concrete or massive concrete. Standards are for general no need of report on thermal and volume change effect on cracking of mass concrete. ACI 2072R, when that is ACI 2075 a roller compacted mass concrete, Very important these ACI codes are guide to mass concrete, report on thermal and volume changes, effects on cracking of mass concrete, roller compacted mass concrete, then ACI 213 guide for structural lightweight aggregate concrete, then ACI 214 evaluation of strength test results of concrete, then ACI 221 guide for use of normal weight and heavy weight aggregated concrete, then ACI 237 R07 self consolidating concrete, then ACI 301 specifications for structural concrete, ACI 304 guide for measuring, mixing, transporting and placing of concrete, ACI 304 to placing concrete by pumping methods, ACI 318 metric building codes, requirements for structural concrete commentary, ACI 506 guide to shotcrete, ACI 5061 guide to fiber reinforced shotcrete, ACI 5062 specification for shotcrete, ACI 555 removal and reuse of hardened concrete, ASTM 820 specification for steel fibers for fiber reinforced concrete, ASTM C31 practice for making and curing concrete test specification specimen in field, ASTM C33 specifications for concrete aggregates, ASTM C39 test methods for compressive strength of cylindrical concrete specimen, ASTM C42 test methods for obtaining and testing drilled cores and sawed beams of concrete, ASTM C94 specifications for ready mixed concrete, ASTM C192 practice for making and curing concrete test specifications, laboratory, ASTM E119 test methods for fire tests of building construction and materials, ASTM C138 test methods for density, unit weight, yield and air content, gravimetric of concrete, ASTM C150 specification for Portland cement, ASTM C172 practice for sampling freshly mixed concrete, ASTM C173 test methods for air contents of freshly mixed concrete by volumetric method, ASTM C231 test methods for air content of freshly mixed concrete by pressure method, ASTM C232 test methods for bleeding of concrete, ASTM C311 test methods for sampling and testing fly ash or natural pozzolanas for use in Portland cement concrete, ASTM C387 specification for packaged dry combined materials for mortar and concrete, ASTM C597 test methods for pulse velocity through concrete, ASTM C617 practice for capping cylindrical concrete specimen, ASTM C618 specification for coal fly ash and raw or calcined natural pozzolana for use in concrete, ASTM C637 specification for aggregates for radiation shielding concrete, ASTM C638 descriptive nomenclature of constituents of aggregates for radiation shielding concrete, ASTM C803 test methods for penetration resistance of hardened concrete, ASTM C805 test method of rebound number of hardened concrete, ASTM C856 practice for petrographic examination of hardened concrete, ASTM C900 test method for pull-out strength of hardened concrete, ASTM C989 standard specification was slag cement for use in concrete and mortars, STMC 989 is standard specification for slag cement for use in concrete and mortars. ASTMC 1018 test method for flexural toughness and first crack strength of fiber reinforced concrete. ASTMC 1116 is specification for fiber reinforced concrete. ASTMC 1140 practice for preparing testing specimens from short grid test panels. ASTMC 152 is standard test method for acid soluble chlorides in mortar and concrete. ASTMC 1218 is standard test method for water soluble concrete chloride in mortar. Standard test method for water soluble chloride in mortar and concrete. ASTMC 1231 practice for use of unbonded caps in determination of compressive strength of hardened concrete cylinders. ASTMC 1240 specifications for silica fumes used in cementitious mixtures. ASTMC 1385 practice for sampling materials for shotcrete. ASTMC 1399 testing method for obtaining average residual strength of fiber reinforced concrete. ASTMC 1480 specification for packaged pre-blended dry combined materials for use in wet or dry shotcrete application. ASTMC 1550 test method for flexural toughness of fiber reinforced concrete using centrally loaded round panel. ASTMC 1604 test method for obtaining and testing drill code of shotcrete. Test method for obtaining and testing drill cores of shotcrete. ASTMC 1609 test method for flexural performance of fiber reinforced concrete using beam with third point loading. ASTMC 1611 test method for slump flow of self-compacting concrete. Test method for slump flow of self-compacting concrete. ASTMC 1666 specification for alkali resistant glass fiber for GFRC and fiber reinforced concrete and cement. ASTM D575 9 guide for characterization of coal fly ash and clean coal combustion fly ash for potential users. ASTM D6942 test method for stability of cellulose fibers in alkaline environments. BRE digest for 33 recycled aggregate. BS4027 specification for sulfate resistant Portland cement. BS6073 to 2008 precast concrete masonry units guide for specifying precast concrete masonry units. BS8500 concrete complementary British standard to BS EN 2061. BS8666 specification for scheduling, dimensioning, bending and cutting of steel reinforcement for concrete. BSEN 2061 concrete specification, performance, production and conformity. BSEN 450 fly ash for concrete definition, specification and conformity criteria, that is for fly ash. BSEN 7713 specification for masonry units, aggregate concrete masonry units, dense and lightweight aggregate. And BSEN 7722 methods of test for masonry units, determination of percentage area of voids in masonry units by paper identification. BSEN 12350 testing fresh concrete. BSEN 123501 testing fresh concrete part 1 sampling. Then BSEN 123502 testing fresh concrete part 2 slump test. Then BSEN 123503 testing fresh concrete part 3 Webby test. BSEN 123504 testing fresh concrete part 4 degree of compactability. BSEN 123505 testing fresh concrete part 5 flow table test. BSEN 123506 testing fresh concrete part 6 density. BSEN 123507 testing fresh concrete part 7 air content pressure methods. BSEN 12390 testing hardened concrete. BSEN 12390 testing hardened concrete part 1 shape, dimensions and other requirements for specimen and molds. BSEN 123902 testing hardened concrete part 2 making and curing specimens for strength test. BSEN 123903 testing hardened concrete part 3 compressive strength of test specimen. BSEN 123904 testing hardened concrete part 4 compressive strength specification for testing machines. BSEN 123905 testing hardened concrete part 5 flexural strength of test specimen. BSEN 123906 testing hardened concrete part 6 tensile splitting strength of test specimen. BSEN 123907 testing hardened concrete part 7 density of hardened concrete. BSEN 12390-8 testing hardened concrete part 8 depth of penetration of water under pressure. BSEN 12620 aggregate for concrete. BSEN 15167 ground granulated blast furnace slag for use in concrete mortar and grout conformity evaluation. BSEN 1744 test for chemical properties of concrete of aggregate. BSEN 1992-3 2006 Eurocode to design of concrete structures liquid draining and containing structures. BSEN 1993 2006 UK National Annex 2 Eurocode to design of concrete structures liquid draining and containment structures. BSPD 66821 aggregate for concrete guidance and use of BSEN 12620. Concrete Society Report number 31 permeability testing of site concrete. EN 1011 welding recommendation for welding of metallic materials. EN 1992-1-1 Eurocode to design of concrete structures. General rules and rules of buildings. GSO ISO 1921 GSO stands for Gulf Standards Organization ISO testing of concrete part 1 sampling of fresh concrete. GSO ISO 19202 testing of concrete part 2 properties of fresh concrete. GSO ISO 19203 testing of concrete part 3 making and curing test specimens. GSO ISO 19204 testing of concrete part 4 strength of hardened concrete. GSO ISO 19205 testing of concrete part 5 properties hardened concrete other than strength. GSO ISO 19206 testing of concrete part 6 sampling preparation preparing and testing of concrete core. That is GSO ISO 19207 testing of concrete part 7 non-destructive test on hardened concrete. ISO 19208 testing of concrete part 8 determination of drying shrinkage of concrete for samples prepared in field laboratory or in laboratory. ISO 19209 testing of concrete part 9 determination of scrape of concrete cylinders in compression. ISO 1920-10 testing of concrete part 10 determination of static modulus of elasticity in compression. CSTR11 concrete core testing. Concrete Society RILEM CPC 11.3 absorption of water by immersion under vacuum. Concrete Society CS163 guide to design of concrete structures in Arabian Peninsula. European guidelines for self-compacting concrete specification, production and use. Now definitions. And exposure conditions will apply as follows. Exposure conditions shall apply as follows: class X0, class X1, class X2, class X3, class X4, class X5, and these are there. Let's say one by one. Class X0, no risk of corrosion. X0 means corrosion, no corrosion. No risk of corrosion or attack, no saline condition, blinding concrete, non-reinforcement concrete, reinforced concrete or slab on ground. This is class XO. Class X1, mild exposure, non-saline conditions, dry or wet, rarely done, dry. External concrete at least 3 meters above ground level. External concrete at least 3 meters above ground level. Internal concrete in dry conditions. Concrete permanently submerged in non-saline water or non-aggressive groundwater. Class X2, moderate exposure, non-saline conditions, cyclic wet and dry, external reinforced concrete less than 3 meters above ground level. Water retaining structures exposed to fluctuating water level. Class X3, aggressive exposure. Now at 3 you can say, as a question, aggressive exposure, permanently submerged or wet, rarely dry, concrete in contact with groundwater, including capillary rise zone. Say, is concrete in contact with groundwater, including capillary rise zone, concrete containing or permanently exposed to saline water. Now class X4, severe exposure, moderate humidity, moderate humidity, external concrete within 1 kilometer from sea or in contact with high saline water, table or subcast is the word subcast. Subcast means saline water table or subcast. Concrete not affected by condensation, irrigation or leakage, which are more than 3 meter above ground level. Class X5, extreme exposure, cyclic wet and dry external concrete within 1 kilometer from sea. Previous was, you see X4 is all within 1 kilometer from sea. It's also 1 kilometer sea or in contact with high saline groundwater or subcast. Concrete affected by condensation. There was no effect of condensation. In number 4, it is affected by condensation, irrigation or leakage, which are less than 3 meter above ground level or within capillary zone. Concrete surfaces exposed to seawater, splash or in seawater, tidal zone. So X5 is critical. Then sulfate exposure classes S1 to S4. Exposure classes are related to sulfate attack in relation to sulfate and pH of groundwater. Concrete is a mixture of cementitious materials, coarse and fine aggregate, and water with or without admixtures, which develops its properties by cement hydration. Cementitious materials, Portland cement in combination with one or more of following blended hydraulic cement, fly ash and other pozzolans, ground granulated blast furnace slag, and silica fumes subject to compliance with requirements of this specification. Water cements ratio shall mean ratio between total weight of water in concrete less water absorbed by aggregate and weight of cementitious materials expressed as decimal fraction. Admixtures shall mean a material other than water, aggregate, cementitious materials or fiber reinforcement used as an ingredient of concrete or mortar. Admixtures are added during mixing process of concrete to modify properties of concrete mixed in fresh and or hardened state. Hot weather shall mean combination of following conditions that tends to impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss and rate of cement hydration, or otherwise causing detrimental results such as high ambient temperature. When shade temperature is above 40 degrees Celsius on a rising thermometer, 43 degrees Celsius on a falling thermometer, high concrete temperature, low relative humidity, high wind speed, and whenever rate of evaporation exceeds 0.75 kg per meter square per hour. Mass concrete, let us say what it is actually, it is massive concrete. There's certain confusion in this. Is defined as volume of concrete with dimensions large enough to require measures to be taken to cope with generation of heat from hydration of cement and attendant volume change to minimize cracking. Reinforced massive concrete structures include pile caps, transfer plates, and structural members where least dimension exceeds 1.5 meter. Coarse, so this is for massive concrete, remember. There's a thick element also which is not given in this, where least dimension is always more than 80 centimeter and quantity is 8 cubic meter. In this, it's more than 1 pi meter because this is massive concrete, massive block, and there's no limit, always more than 8 cubic meter. Coarse aggregate shall be considered as that size passing a 20 sieve or larger sieve and predominantly retained on a 4 sieve, which is coarse aggregate passing through 20 sieve and predominantly retained on 4 sieve. Means this is coarse aggregate which should be between 4 and 20 Fine aggregate shall be considered as that size predominantly passing 4 sieve and predominantly retained on 0.063 So that is between 4 and 0.063 That's called fine aggregate, or you may call it stone dust, or you may call it coarse sand, whatever you can say. Coarse aggregate is not coarse sand, remember. Coarse aggregate is actually 20 and 4. Coarse sand and fine sand both come under fine aggregates. PC shall mean Portland cement, or CEM1. FA shall mean pulverized fuel ash or fly ash, and GGBS means, you know very well, ground granulated blast furnace slag. SF shall mean silica fume. Other names are condensed silica fume and microsilica. Gap graded aggregate shall mean graded aggregate without one or more of intermediate sizes. Single size aggregate means aggregate containing a major proportion of particles of one size. Target mean strength shall mean specified characteristic strength plus margin. Margin shall mean difference between specified characteristic strength and target mean strength. Accepted shall mean acceptable or accepted by engineer. Approval or approved shall mean approval from engineer. All in aggregate shall mean materials composed of a mixture of coarse and fine aggregates. Self-compacting concrete SCC. Concrete is able to flow and consolidate under its own weight. Able to flow and consolidate under its own weight. Completely fill formwork even in presence of dense requirements, whilst maintaining homogeneity and without need for any additional compaction. Submittals. Contractors submit details of mixed designs to engineer for approval. Material safety data sheet MSDS or equivalent for all products. Test results and other information as required to prove compliance with the specifications shall be submitted to engineer for approval according to relevant section of QCS on at least following products: cement. Recent independent test results acceptable to engineer confirming compliance with specified requirements and reference standards. Manufacturer certificates shall also be supplied for each batch of production of cement or on a weekly basis, whichever is more frequent, certifying compliance with BSE 197 or other equivalent standard. Early compressive strength of each consignment of cement shall conform to requirements of QCS Part 3 at independent site laboratory. Deviation of more than 10% from either previous consignment value or rolling average shall be immediately reported to engineer. Testing at an independent laboratory shall be as instructed by engineer. GGBS. Recent independent test results acceptable to engineer confirming compliance with specified requirements of reference standards. Manufacturer certificate with information necessary to verify compliance shall also be supplied for each consignment of GGBS or on weekly basis, whichever is more frequent. Early compressive strength of each consignment of GGBS shall be determined in accordance with BSE 197 and BSE 15167 or ASTM C989 at independent site laboratory based on blend of 50% GGBS and CM1. Deviation of more than 5% in strength from either Previous consignment value or rolling average shall be immediately reported to engineer. Testing at an independent laboratory shall be in accordance with per BSEN 197 and BSEN 15167 standard and approved by engineer. FA, that you know what is fly ash. Recent independent test results acceptable to engineer conforming compliance with specified requirements of BSEN 450 or ASTM C618. Manufacturer certificates with all information necessary to verify compliance with internationally recognized standards shall also be supplied with each consignment of fly ash. Material shall comply with QCS Part 3 deviation of strength factor by more than 5% from either previous consignment value or rolling average shall be immediately reported to engineer and technical manager of premix company. Silica fumes or microsilica, I can say. Recent independent results acceptable to engineer conforming compliance with specified requirements and reference standards. Manufacturer certificate with all information necessary to verify compliance with internationally recognized standards shall also be supplied with each consignment of silica fumes. 7 days pozzolanic activity tests in accordance with BSEN 13263-1 or ASTM-C 1240 on each consignment of silica fumes at independent site laboratory. Deviation of activity indexed by more than 5% from either a previous consignment value or rolling average shall be immediately reported to engineer and technical manager of premix company. Aggregate recent independent test results acceptable to engineer conforming compliance with specified requirements and reference standards. Full details of proposed sources of aggregates. Water. Recent independent test results acceptable to engineer conforming compliance with specified requirements and reference standards. Now, admixtures. Recent trial results acceptable to engineer illustrating efficiency of product for its particular application. Tests on specific gravity and solids content shall be conducted at independent site laboratory on each consignments. Mix designs. Submit concrete mix designs for each type and strength of concrete required at least 30 days before placing concrete. New mix designs with historic data less than 6 months shall be verified by an approved independent testing laboratory in accordance with requirements of QCS Part 5 and shall be coordinated with design requirements and contract documents. Submit complete mix design data for each separate mix to be used on project in a single submittal with at least following information: type of cement, Portland cement content, cementitious content, GGBS, FAs, fly ash, natural pozzolana, risk husk ash or silica fumes, maximum aggregate size, combined grading curve for coarse aggregate, quantities of all individual materials, type of admixtures, then target slump flow at discharge as per BSEN 123502, initial and final concrete setting times for each mix designs for ASTM C403 or equivalent BSEN standards with fresh density of concrete per BSEN 12350-6, air content per BSEN 123507, target temperature, bleeding specified chloride and sulfate SO3 contents, details of calculated water cementitious material WCA water cement ratio, compressive strength grade, hardened density, water absorption percentage and water penetration mm if specified, rapid chloride permeability, column value if specified, chloride migration coefficient meter square per second if specified, include on delivery ticket as a minimum mark. Data shall be from same production facility that be used for project. Mix design data shall include but not be limited to following: location on project where each mix design is to be used, corresponding to structural general notes on drawings. Proportions. Concrete constituent material shall be proportioned to yield 1 meter cube Submit stand test records, mix design materials, conditions, and proportions for concrete use for record for tests, standard deviation calculations, and determination of required average compressive strength if required by engineer. If early concrete strength is required, contractor shall submit trial mix results as required. Test records to support proposed mixtures shall be no more than 12 months old and use current cement and aggregate sources. Test records to establish a standard deviation may be older if necessary to have required number of samples. Manufacturer's product data for each type of admixtures. Manufacturer certifications that all admixtures used are compatible with each other. All information indicating compliance with contract documents, including methods of placement and methods of curing. Mass concrete, which is called massive concrete, submit mix design for massive concrete element in conformance with requirement of ACI 301 section 8. Concrete mix design shall not be designed with a high early strength unless otherwise demonstrated by contractor for capability of maintaining proper temperature and approved by engineer. Submit proposed methods of temperature control, including cementitious material content control in mix design to reduce heat generating potential of concrete. Pre-cooling of ingredients to lower concrete temperature as placed, and methods to protect mass concrete elements from excessive temperature differentials. Submit analysis of anticipated thermal development within mass concrete elements with proposed mix designs for these elements. Results of analysis using method in ACI 2071R and ACI 2072R, such as a schematics model and site specific data, shall address maximum differential temperature and maximum temperature during concrete. Submit proposed number and locations of temperature monitoring devices to record temperature development between interior and exterior of mass concrete elements. Now this is page 41 that so far I have reached out of these 205 pages. I think it's not possible for me at this stage to continue it for long. It's already more than 2 hours and I'm tired because of my health conditions, so I could continue for couple of hours, but due to my conditions I'm stopping it here. I think you'll get benefit of this because if you are not sure about quality of concrete, what concrete should be, simply pouring is not adequate. Simply depending on something, you have to understand thoroughly what concrete is, how to design, what to understand about these ingredients of concrete that we have gone through, including water. You have to understand this very well. Is an important point of view. This we must understand all time. If we don't understand this, it's same thing as we don't understand design, because this is equal to design. It is very important that this is means we have to be thorough in designing concrete, in applying concrete. Otherwise, we waste our time, we waste our energies. There is no meaning at all in that case. I hope you understand. I shall continue if my health permits, because I am bedridden. Again, I am saying I am bedridden. I am completely bedridden. I can't move my leg, so I am even passing my discharges, urine, and my sweating all in bed. So whatever I could do, I will try to share with you. With this, I close this one now. I close this for time being, and because it's already more than 2 hours. I also discussed you long back. I'll discuss with you. I'll share with you this concrete as well as also test reports that I shared in the past. I could not complete that. I shall try to complete that also if possible, because I'm sharing documents which are very important, because I can't remember everything and I can speak. No, it's not possible. So we have to sit together, understand this, how it can be done. Only then there's a possibility of being professional. If you don't have professional information, if you do not concentrate on these documents, There is no meaning to work as an engineer, believe me. There is no meaning to work as contractor, believe me. Its important quality of concrete must be maintained, which is not being maintained in our country. We are just taking everything easy. I'm not criticizing this. This is a fact which I have seen. Even big companies cannot do that because engineers don't force them. It's duty of every engineer to force contractor to do job according to requirement. It doesn't matter which code we use. Information must be there. Important points. What concrete is? Concrete is very big technology. We cannot just sit and see what's happening here and here. We have to concentrate on each and every provisions in specifications that can give us immense knowledge, and further we have to think on that. It's very important point, not simply saying I know it, I do it. Our job is not physical alone. Physical job supported by quality requirement, supported by this and that. That's very important. We have to think about that. It's very important point. That's why I'm stressing. We have to do this. Otherwise, means you may say we are just wasting time. We don't want to waste time. We want to use time. And to particular those engineers who are new, who are fresh, who are budding, who are earning experience in life, they should be very serious. Getting job is easy, but doing job is not easy. Remember, if you are in international field, you cannot work otherwise. Maybe here you can work successfully, you can be full public, but you see bridges are falling, buildings are falling, everything's happening because there is absence of quality system, there is absence of everything. The specifications are not available and are not properly understood. Even if these are available, very remote one. For example, people don't know what GGBS, what microsilica is. They hear names, but they do not know what outcomes, incomes of those are. But just talking and talking and talking without understanding doesn't mean engineering. Seminars conducted for a couple of 1 hour, half hour, and 10-15 minutes are given to a speaker, which they just waste time and do nothing. So, my dear friends, my dear colleagues, I'm just trying to share my information with you with an understanding that don't give me credit, I do not need credit, just take it, just use it. Because whatever small knowledge I have, whatever lower knowledge I have, it's because of experience and not because of books. Books did not give me any knowledge, except very elementary knowledge. And I haven't gone through higher degree books also. I could not get what I wanted from them. But it's job that equipped me what I'm talking about, and I want to learn more and more about this because when I worked in 85 in Gulf or 96 in Doha, Qatar, this same specification of concrete was very, very limited. Now it's very expensive, expanded one, and I'm happy with that. Information that I'm getting now wasn't available that time except this 4 degrees to 32 temperature. Now the water temperature is how much, inside of concrete is how much, external is how much, difference of internal concrete of massive block and external concrete is how much. There's so many provisions that I could not get that time. What about curing, thermal curing, chloride curing, curing compound use, all that. Lot of changes are there, and that's what is technology says. Technology develops like that. Durability requirement, which is an integrated part of reliability means. So we say reliability is very important. Yes, reliability is very important. Our work should be reliable. It's not simply work, it should be reliable. That's where we stand. So I think I should not go further ahead on explaining. I continue. It's already, I think, more than 2 hours and 20 minutes. And I think maybe you get something out of this. You are interested. It depends upon your interest. You may kind of okay, leave it. Okay, leave it, no problem. It's your loss, not my loss. I'm just trying to enrich your knowledge if you take interest. If you say no need, I'm structural engineer, I know everything. Okay, then congratulations, remain a structural engineer, remain civil engineer, whatever you want to do. But remember, there is no meaning of being a structural engineer if you don't know about all this. This is first requirement in design. If you don't know concrete, what's the meaning of design? Tell me. If you don't know temperature control, what's the meaning of design? Tell me. If you don't know how to protect concrete from how to protect steel from what's the meaning of design? Tell me. All these count. That's why I'm stressing. Work on site, concrete particularly, is a part of structural engineering. You may accept, you may not accept. It doesn't make a difference on my health. It shall make a difference on your professional health. It's not time of 40 years, 30 years back. It's current, where quality means something. And if you don't do that, drawings don't mean anything, designs don't mean anything. If you understand quality and then design, you can reflect in your design what you mean by that. You can tell people what you have to do. You can write a specification on drawing itself, brief specifications, what they have to do. That is more important. Site people should not run from pillar to post to find what should be done. That is main point I am trying to stress. And if you can do successfully, maybe you suffer in beginning. You have to read a lot. You may not like to read a lot, then you will not get job. You will not get opportunity. Remember, future is for civil engineer. If one is real civil engineer, don't think of becoming a structural engineer directly. If you are a good civil engineer, you can convert yourself to structural engineer without problems. If you can do good delivery, quality delivery of concrete, you are an engineer, structural engineer. You can convert